Let's talk about high-pressure piping. It sounds pretty straightforward, but if you get it wrong, you're not just looking at a simple leak. You're looking at a potential explosion. This is a world where every single connection has to be absolutely perfect. So today, we're going to break down the field guide to containing that immense energy and how to get it right every single time.
So to get us started, I want to ask you a question, and it might sound a little strange. What on earth could a tire on a race car possibly have in common with a thick, heavy steel pipe out in the field?
Well, the answer is a whole lot more than you'd think. See, both are engineered for extreme performance. Both are put under incredible, intense wear. And in both situations, if you fail to understand their limits, it can be absolutely catastrophic. Stick with me on this, because that analogy, it's the key to understanding everything we're about to cover.
Okay, first things first. Before even one piece of pipe hits the ground, you've got to choose your equipment. This is the foundation of the whole operation, and it has to be perfectly suited for the job you're about to do.
Now, your very first line of defense is actually brilliantly simple: a color code. Each one of these colors tells you the working pressure it's rated for, in PSI, pounds per square inch. You see black, you know that's for 10,000 PSI. White, 15,000. It's a quick visual check that is so important for preventing a deadly mismatch right from the start.
And speaking of mismatches, let's talk about one of the most dangerous and, surprisingly easy mistakes you could make out there. It's called the hammer-union mismatch.
And here's the trap. A high-pressure figure 1502 nut, it will actually screw right onto a lower-pressure figure 602 sub. It feels like it fits, it even tightens up, but, and this is critical, it will absolutely not hold pressure. We're not talking about a small drip, we're talking about a catastrophic failure. That's exactly why figure 602 unions are just forbidden. It creates a dangerous illusion of a safe connection, and you have to be trained to spot it and avoid it.
Standard seals are great, but they have their limits. When you get into what's called an HPHT environment, that's high pressure, high temperature, think over 10,000 PSI, over 250 degrees Fahrenheit, or if you're dealing with nasty stuff like sour gas, you need to step up your game. You have to use metal-to-metal seals. Why? To stop something called explosive decompression. Just imagine gas, under all that pressure, getting forced into the tiny pores of a rubber seal. If you release that pressure too fast, the trapped gas expands violently and literally shreds the seal from the inside out. Metal seals, they prevent that.
All right, so we've got the right gear picked out. Now it's time to actually build the line. And this is where technique is absolutely everything. Every single connection you make is a potential point of failure, so getting the assembly perfect isn't just a goal, it's non-negotiable. A smart layout is a safe layout, simple as that. You want to use as few elbows as possible, because every turn creates turbulence that just eats away at the metal over time. You have to have a meter of straight pipe after a choke to let that crazy flow calm down. You keep your pipes up on blocks, never on the ground where they can get damaged, and you always follow the flow. Fluid goes in the female end and out the male end. It's designed that way so the pressure actually helps seat the internal seals correctly instead of trying to blow them out.
And this right here shows the perfect technique. A hammer is not a tool for forcing a bad connection together. Step one is always to align it and tighten it by hand. If you can't get it hand tight, stop. It means the pipe is misaligned, it's under strain. You have to fix that alignment. Only after you've got that perfect, strain-free, hand-tight fit, only then do you pick up the hammer to secure it.
I really want to pause on this one, because there is zero room for interpretation here. This isn't a suggestion, it's not a best practice, it is a mandatory rule. Every single temporary high-pressure line must have safety slings. Think of them as seatbelts for your pipework. They're there to contain that terrifying energy if a connection ever lets go.
And here's how you do it right. You use a half hitch or a choke hitch, and you make absolutely sure that sling is anchored to something heavy and solid that's not going anywhere, like the separator skid. A restraint is only as strong as the thing it's tied to.
Okay, so the line is built, it's secured. Now comes the most critical part of all, the operation. The system is live, it's under pressure, and from this moment on, your own vigilance is the single most important piece of safety equipment you have. Before even 1 pound of pressure goes into that system, you walk the line. This is your final check, a physical, hands-on verification of every single component. You lay eyes on every union, you confirm every valve is set exactly where it needs to be, and you double-check every single safety sling.
There are no exceptions to this. None. So, how do we really know it's safe? Well, we tested way beyond what it's expected to handle. All the equipment gets pressure tested to 1.2 times the maximum potential pressure it could ever see from the well. That built-in safety margin, it's not negotiable. 2. Just the number 2. This number represents one of the most important timers you need to be aware of in a high erosion situation. So, what do you think has to happen every time this timer goes off? Every 2 hours. That's the answer. When a well is kicking out solids, like sand, that fluid basically turns into a sandblaster on the inside of the pipe. It can wear through a pipe wall with terrifying speed. So the rule is crystal clear. You check that wall thickness with an ultrasonic tool every 2 hours. And that brings us to a really important term. That 2-hour check, it's part of the safety protocols for what we call a harsh job. But what does that actually mean? What makes a job harsh?
Well, a job gets the harsh label if it meets any of these 3 conditions. 1, really high flow rates. We're talking over 30 million standard cubic feet of gas a day or 8,000 barrels of oil. 2, if there's any sand present at all. And 3, if you've got high levels of corrosive gases. Remember our race car? This is like driving it at top speed but off-road through a sandstorm. The potential for wear is just enormous, so your level of vigilance has to match it.
So the job's done, pressure's off. But your responsibility doesn't stop there, not at all. The work you do after the job, the maintenance, the inspection, that's what makes sure this equipment is safe for the next job. And that process is super structured. After every single job, no matter what, it gets a visual inspection. Every year, it gets a full thickness measurement. Or, importantly, right after any harsh job. Every 5 years, it goes in for a major recertification with magnetic particle inspection and another pressure test. And then, at 20 years, its service life is over. Done. It's retired from service. So let's bring this all full circle and go back to that race car tire we started with. Because this analogy, it really does perfectly capture the whole philosophy behind high-pressure pipe safety. High flow rates, that's your speed. Sand and solids, that's your rough off-road terrain. Both of those things are going to wear down the tread on your tire, or in our case, the wall thickness of the pipe. And that's why you absolutely must measure the tread, the wall thickness, after every single harsh job. If that tread gets too thin, you don't try to patch it, you retire it. You get a new tire, period. No exceptions. And really, that's the whole point. Safety isn't just about blindly following a list of rules. It's about understanding the physics of wear and the real risk of failure. So I'll leave you with this question. The next time you see a high-pressure line, are you just going to see a piece of steel? Or are you going to see the tread on the tire, constantly wearing down and demanding your absolute respect and vigilance?